Hi, Math 103, Chapter 6, Section 6.1 and 6.2. I'm sorry, the first page is not very clear. That's why I wrote the definition here. And one definition is for random variable. What is random variable? Random variable is a variable that has a single numerical value that always determined by chance. So it's like when you select some people out of a big group, it considered as a random variable because randomly you select some by chance. And then next is the probability distribution, is a table that gives probability for each value of the random variable, which on the next page or so, when you see the example, then all this definition will become very clear to you. Here, we are normally dealing with two types of variable. One they call it discrete. Discrete always take whole number, and the other one is continuous variable. So what's the main difference between these two? One, it always take the whole number. Second one can take the decimal number as well. Now, probability always has to be, sum of the probability always has to be 1, and probability cannot be negative. Probability is always between 1 and 0. Example of probability be equal to 1 or 100%, 100% is a 1. It's like, what is the probability of Thanksgiving be on Thursday? Probability of Thanksgiving be on Thursday is 100% or it's 1. Or what is the probability of Thanksgiving be on Wednesday? 0%. So probability always stay between 1 and 0 and is positive between 0% and 100%. What you see here is distribution, probability distributions. Probability distribution has two columns. One column shows all the X and the other one shows the probability. Like here, X is the number of heads when two coins are tossed. So when two coins are tossed, what's the probability of getting no head? 25%. What's the probability of getting one out of two coins are landing with heads? 50%. What's the probability of both of them land with heads, faces? 0.25. What you need to remember is probability distribution is valid when sum of the probability is always 1. So that's the very first thing you need to check to make sure the probability, the sum of the probability is always 1 or 100%. And you understand that probability has to be positive and is always between 0 and 1. See, you don't have the negative one here. Probability is positive here. All right, so now here, I made an example of what is the discrete? Count of number of movie patrons. When people walk into a movie theater, the number of people is discrete. But on the other hand, altimeter, it gives you a decimal number. So since it takes a decimal number, is a continuous random variables. So there are two types of random variables. One is discrete, which always take the whole number. The other one is continuous, that also takes a decimal number. Then on the next page, I'll show you some example here, like, is the number of statistic student, is it discrete, random, or not? Number of statistic student, you have 20 students, 30 students. See, it's a whole number, right? So it's discrete. Is the square footage of the house discrete, or a square foot of the house, can that take the decimal number? Can we say my house is, I don't know, 1150.50 or 752.7? Yes. So a square footage, since it's taking also a decimal number, it could be a continuous. Is the political party affiliation adult in the United States discrete, random, or none? It's not. It's not a discrete number. You're not talking about the numbers. You're talking about political party affiliation of the adults. Is the number of people with blood A? Number of people. They're talking about number of people. So it's a whole number. It's discrete. Is exact time it takes. Times Can time takes a continuous? Yes, it's 7.8 minutes. It's 12.7 minutes. So it is continuous. So what's the main difference between continuous and discrete? Discrete take the whole number, and continuous takes the decimal number. Like weight also can be decimal, right? It's 200.7 pounds or 218.9. So it is that weight up, like in this case, weight of a T-bone steak is a continuous variable. So that's the main difference between continuous and. So based on that, you should be able to answer the question here. And this is homework assignment, and like for instance, number of window, discrete is the correct answer. So you may go through this example and practice for discrete and continuous. This one also, I put the page here for you that, there are 4 slips here. And first, when you select 2 of these, what is all the possibilities? These are all the possibility when you select 2 out of 4. On part A, sum of 2 numbers, okay? And then difference of the first and second number. So you should be able to, read the solution for those examples. This is again another some example of discrete and continuous. They just ask for all the positive. A person is standing at the corner at A and mark A, square picture, and toss a coins. If the coins goes head, you move forward. If the toss shows tails, then you go backward. You go in this direction. Okay. So all positive even integers for this one. So this one, I'll show you the example. This is another example, the 2 6-side dice. Dice number 1, each dice has 6 faces, right? So we show all the possibilities. These are all the possibilities. And the base of that, we could answer question, sum of 2 numbers showing 2, 3, 4. How many, numbers? 1 plus 1 is 2, 1 plus 2 is 3, 1 plus 3, 4. See, you don't just repeat the one that you already have, and you don't repeat that. Now, probability distribution, again, is like in this example, what is the probability when x is 0? This is a problem. This is given the problem. This is given the problem. Probability of x 1, 2, 3, 4. First, you have to check to make sure that sum of the probability is always equal to 1, and every single probability is positive. Okay, positive sum is 1. And here is the histogram for this one. You understand that the width of this rectangle, they all have equal width. The distance of here is all equal. It's just the height are different. Probability is on the vertical axis. Probability shows out the heights. And area of each rectangle is the probability. Okay, like what is the probability of x equal 1? X equal 1 is this one, right? Height of this rectangle is 0.3456. To find the area of rectangle, you always multiply the height by the width, but all of them, the width is 1. So area of this rectangle is height, which is 0.3456, from here to here, multiplied by 1. See? So probability is area of each rectangle, and the total probability is when you add the area of all these rectangles together, sum should be 1. This is another examples. These are all the x's. Instead of using the vertical column, we are using the horizontal column. Probability of all of these are given and we draw. Now, for instance, what is the probability when x is between 5 and 2? Between 5 and 2 is all this, right? So you have to calculate probability of 2 plus probability of 3 plus probability of 4 plus. So when we ask you to find the probability between these two numbers, means you need to find the area. this area, which is area of this rectangle plus this plus this plus that. Probability of 2. Question mark. The answer for this one, I put it here for you. We understand that sum of the probability always has to be 1. So if 1 is unknown and we know sum of this is 1, see? So the unknown one should be 0.02 because when you add all these numbers, the sum has to be 1. Like, what's the probability when it's less than equal to 2? Less than equal to 2 means you find probability of 2, 1, and 0. What is the probability of y less than 2? If you don't see equal sign, means 2 is not one of them. So because it doesn't have equal sign like this. See, that means just y equal 1 and y equal 0. Means you just add these two together. And so on. At least this is for number F. What's the probability if at least 10 eggs are broken? That means when 10 is broken, 10 is unbroken, means 2 broken. 1 broken, 0 no broken. So you change it to probability of y equal 10, 11, and 12, which is probability of 2, 1, and 0. Okay. So again, here, why we are taking probability of x equal 2? When 10 is unbroken, means 2 broken. Probability of at least 10 means probability of 10, 11, 12. 10 means x equal 2. 11 unbroken means 1 broke. 12 unbroken means none of them broke. Okay. So these problems are all the same. In this one, they are saying that probability of homeowner having insurance is 10%. What's the probability of homeowner do not have insurance? If 10% have insurance, 90% do not have insurance. X equals 0 means what is the probability of, because we are selecting 4. See, they're talking about 4 homeowner. 4 homeowner. 4 homeowners are selected at random. What is the probability of none of the 4 has insurance? Is 0.9 times 0.9 times 0.9 times 0.9. Or here, what is the probability of all 4 randomly selected people have insurance? So in that case, 10% times 10% times 10% times 10%. These are all the possibilities. They are saying S is for has no insurance, S has insurance, F is no insurance. So this is no insurance, yes, yes, yes. Yes, no insurance, yes, yes. So these are all the possibilities when X is 3. X is 3 means 3 out of 4 people have insurance. 3 out of 4 people have insurance. So this is in order. The first, when you randomly select 4 people, the first one doesn't have insurance, but the last 3 do. Or the first one has, the second one doesn't have, and the third and fourth does. Or the first 2 have insurance, the third one does. So these are all the possibilities when you are selecting 4 people and see if they have insurance or not. Just one, in this case, X equal 3 means 3 out of 4 must have insurance. 2 must have insurance. So these are all the possibilities. So when you have the table, then you should be able to answer, like, what is the probability of x is less than equal to 3? Less than equal to 3 means you take these 4 numbers and add. X less than 3, it doesn't have equal sign, means x is 2 plus 1 plus 0. Or you could just, this 3. X greater than 3, x greater than 3 and equal means these 4 numbers, okay? That's all. And they have the solution here. And these are all very similar to that. All right, that's the end of this.